Okay, so here we go. Sample problems, example problems. So if some of the conversation in the pre-lesson threw you, now is the time to kind of explain it less and just show you how to get her done. So what they did is they threw a new word at you though, and this is where words and math kind of like, oh, if I just understand what they're asking. So they start off with this, use long division to rewrite. Like, oh, okay, so this is where the math is going to take place for this. So like, okay, this is x minus 6 going into x. Now this is kind of weird, but it says to rewrite each rational. Now in the problem, in the pre-lesson, they use the quotient. Now, quotient, same thing, just that's a division problem, another word for division. Rational, the root word is ratio, and the word for the actual definition of ratio could be said to be a fraction. So don't panic. You can kind of ignore it, but just so you understand where the words are coming from, they're just saying, hey, take this thing, use long division. It doesn't really matter how they explain it. It's a fractions, quotient, rational function. Don't worry about that. Look at this first term, this first term. Ask yourself, what times this gives me this? Well, that's a 1. Haven't seen that before. But now we got to multiply it by 1, so we get x minus 6. Don't forget, next step you subtract, always, in long division. X minus x, gone. There's like an invisible 0 here, if you want to think of it that way. 0 minus a negative 6 is 6. This is my remainder. This is my answer. So really, if I put these two things together, I get 1 and my remainder over my divisor, which I can take from here or here, x minus 6. Now we got to get a little fancy here. Because remember, this equals f of x. We're just changing the way this looks. So if this is f of x, I'm going to find the asymptotes and sketch the graph. I need to know exactly kind of how this is going to play out. So I'm going to rearrange this. I'm going to really focus on this. So I'm going to take that, I'm going to put it first, 6 times 1 over x minus 6. Having this 6 out in front helps me understand it's a vertical stretch. Now, do you have to do that? No. You can just look at this and go, it's a vertical stretch times 6. But I want to spell this out for you a little bit better, but then the plus 1. So the parent function is 1 over x. We know what that looks like. Looks like this, ish, this, ish. So what do we got to do then? Well, we got to realize it really does have a center. We're going to move the center right 6, up 1. So we're going to go, okay, different colored marker for you. 1, 2, 3, 4, 5, 6. Up 1 would be somewhere in here. So my new y-axis is here, my new x-axis is here, and now I just kind of duplicate it. Now, I know I'm not done because I have this darn 6 here. But what I need to do is try to make this steeper. I know that's hard. So that's going to be closer to the y and closer to the x, and then the same thing over here. Now, how much really difference, does that make? It's just almost impossible to do it like this, okay? So, just know that that's a vertical stretch, okay? Now, what if that was 1/6? Vertical compression, all right. And that's it for that example problem. Oh, no, it's not. I got to sketch it and find the asymptotes. Now, let's get rid of the purple, because it's really not what it's talking about there. So, notice we have a vertical asymptote right there, so it's going to be x equals 1, 2, 3, 4, 5, 6. Now we also have a horizontal asymptote at y equals 1. There, now we got her done. One more sample problem. Okay, so what are the vertical and horizontal asymptotes of this? Well, first thing we're going to do, as noted in the pre-lesson, is we focus on this and this alone, because that's going to spit out our vertical asymptotes. If we just look at it, we have to think, okay, what values for x would cause that to be 0? So we're going to go x squared minus 2x minus 8 is 0. They're going to give you nice little trinomials that are factorable here for now, maybe forever. But there you go. So x cannot equal 4, and x cannot equal negative 2. So what does that mean in my picture? It means my graph will not cross that vertical asymptote, x is 4, because x can't be 4, and x can't be negative 2. So x equals negative 2 is my other equation, the name, the actual name of the vertical asymptote. Now what I said was, you guys can go ahead and type this into Desmos and make sure to put parentheses around that, then hit the division bar and then type that in, and we'll just put it right underneath there and spit it out for you. So what it will look like is this. Again, with a big old ish. And then, interestingly, I'm going to peek at my notes just a second. This one goes something like this. Looks like a cubic. All right? All right, we got it. Now, we got to look for our vertical asymptotes. Nailed them. Are there any horizontal asymptotes? No. Boy, hold on a second. Hold on a second. So we've got this one right here, where this is going up here, and this is actually this x-axis is actually a horizontal asymptote. That almost snuck by me. So y equals 0. Remember, y are all of our horizontal lines. So the actual name of the x-axis, ironically, is y equals 0. So there you go. Okay? But that does not apply to this portion of the graph. This one doesn't have any horizontal asymptotes, but these two do. Boom. All right. Good luck with that homework.